Hi, this is your teacher Barbara Rademacher, and we're going to be adding and subtracting radical expressions, which means we're going to have to simplify them. Because on the surface it looks like you can't add these. These are not like radicals. They do have the same index, but they don't have the same radicand. That is, 24 and 81 are the radicands. But I'm betting we can break these down and find a perfect cube in them. Let's do it. Let's break down 24. 24 is, I don't know, what is it? 6 times 4. 6 breaks down into 2 times 3. And 4 breaks down into 2 times 2. So that 24 equals 2 times 2 times 2 times 3. Look at this. The index is 3, which means we're looking for 3 of the same number, and here it is. There are 3 2's. So what does that mean? It means I'm stuck with red, is what it means. All right. It means that 6 is going to stay there. But 24, all right, the cube root of 24 can be written as 2 times the cube root of 3. The perfect cube comes to the outside once, and the number that's not a perfect cube stays inside. All right, let's do this with 81. 81 will break down into 9 times 9. It's a perfect square, but is it a perfect cube? Well, let's see. 9 breaks down into 3 times 3, and 9 breaks down into 3 times 3, and look at this. I have 3 of the same number, 3, so that 81, the cube root of 81, can be written as 3 times the cube root of 3. One of these 3's comes to the outside, and this 3 stays on the inside. Okay, now let's go back to the left here. This 2 is on the outside of the radical, so it can multiply the 6. So we'll have 12 times the cube root of 3 plus 3 times the cube root of 3. How many cube roots of 3 are there? We have 12 cube roots of 3, and we add another 3 cube roots of 3. So there are going to be 15 cube roots of 3. How about that? Okay. All right, now we're going to take the square root of 12 times minus the square root of 48 plus 4 times the square root of 75. We have to break these down. Remember, there's an invisible index 2 when you're dealing with square roots. So we're going to be breaking down 12, 48, and 75 and looking for 2 of the same number. All right, 12 will break down into 4 times 3, which is 2 times 2 times 3. There are 2 2's. So 12, the square root of 12, now see, it's being multiplied by 2, so I'm going to write 2 out here, and then times the square root of 12 can be written as 2 times the square root of 3. Now I'm going to subtract the square root of 48. 48 is, among other things, you can break it down any way you like, let's break it down into, because this occurred to me, 4 times 12 is 48, and 4 is 2 times 2, which is a perfect square, but wait, let's finish. 12 is 2 times 6, and 6 is 2 times 3. So now we're going to have 48 rather, equals 2 times 2 times 2 times 2 times 3. I'm looking for 2 of the same number. Instead, I have 4 of the same number. But look at this. 2 times 2 is 4. 2 times 2 is 4 times 3. Now I have 2 of the same number. So the square root of 48 can be written with one of these 4's on the outside and then the square root of 3 on the inside. Whew. Now I only have one more to go. I'll have plus 4 times and then the square root of 75. So let's investigate 75. 75 equals 25 times 3, and you probably already know that 25 is a perfect square. It's 5 times 5. So 75 equals 5 times 5 times 3. And here are my two 5's. So I'll be writing the square root of 75 as 5 on the outside and the square root of 3 on the inside. Now, that's my dog scratching. In case you heard scratching, yes, that's my dog. Okay, I'll have 2 times 2 is 4, right? So that's 4 times the square root of 3. And then we're subtracting 4 times the square root of 3. So these two are going to zero each other out. Let me put the minus sign back though. Now, plus 4 times 5 is 20. 20 times the square root of 3. So our answer is going to be 20 times the square root of 3.